All right, this is your favorite teacher here. This time we're doing 4.9, which is modeling with polynomial functions. So a lot of this is done on the calculator, which is really nice. And we saw a lot of this as well in I think chapter 3. We did something like this with the parabola. So the first example here says to write a cubic function whose graph is shown. So we have several things given to us with this graph. We have our x-intercepts and our y-intercept, and that is exactly enough information to write a cubic function for this. So if you know that the zeros are x is equal to -3 and x is equal to 1 and x is equal to 2, then you know that means that we have factors of x plus 3, x minus 1, and x minus 2. So we can set up an equation that looks like x plus 3 times x minus 1 times x minus 2, okay? But we don't know really what the stretch or shrink factor is here, right? We don't, like, for all we know that this graph could dip really low here or only go up that way. And so we have to specify the fact that we have a certain minimum and maximum here, if you will, and we do that by putting an a value on the outside there. Okay, and now our goal is to figure out what that a value is. And how we do that is we use this extra point that they gave us. 3 is your y, 0 is your x, so you plug those values in for each one of those coordinates there. You simplify down, so we have 3 equals a times 3 times -1 times -2, which gives you that 3 is equal to a times 3 times 2, which is 6. Then we divide both sides by 6, so 1/2 is equal to a. And so we finish off by saying y equals 1/2 of x plus 3 times x minus 1 times x minus 2. And that is all that you have to do. You could check your work by plugging that into the graphing calculator and making sure that that was an equivalent graph there. But you don't have to if you're feeling just super confident. So. All right, number 2 says use finite differences, then determine the degree of a polynomial function that fits the data. Then use technology to find the polynomial. Okay, so what we've got here is basically a table of values. And when it says use finite differences, that means that we are going to find the difference between those f of x values, and how many times it takes us to find a common difference is going to classify which polynomial that it is. So to get from -4 to -2, we need to add 2. To get from -2 to -4, we have to subtract 2. To get from -4 to -16, we have to subtract 12. 16 to -44, that is a -28. -44 to -94 is a -50. And -94 to -172 is a -78. So if all of those would have been constant, then we would have had a linear function. But because they're not constant, we have to continue on. So 2 to -2 is a -4. -2 to -12 is a -10. -12 to -28 is a -16. -28 to -50 is a -22. And -50 to -78 is a -28. Now, if all of those would have been consistent, then we would have had a quadratic function or a parabola. But they're not consistent, so we have to keep going. -4 to -10 is a +6, or -6, sorry. -10 to -16 is a -6. -16 to -22, that's a -6. -22 to -28, that's a -6. So hey, look at that. Because those are consistent, then this graph has to be cubic. Okay? So then what we do, so that's the first part, to determine the degree of the polynomial. The degree is 3. Okay, we know that. It's a cubic graph. So then it says use technology to find the polynomial. That's when we go to stat edit. We clear out what's ever in our tables. Okay? And we enter that data. So let me turn on the light so you can maybe see this a little better. There we go. In our list 1, we list all of our x's. So 1, 2, 3, 4, 5, 6, and 7. And then in our list 2, we list our y values, -4, -2, -4, -16, -44, -94, and -172. Now, because we know that it's a cubic graph, when we find the regression, so we hit stat calc, we go down to cubic regression. We found that it was cubic, so we're going to use cubic regression. We're going to click enter until we get a polynomial there. Okay. How we know we're correct is this r squared value is 1. Okay. If that r squared value wasn't 1, then you know that you've chosen the wrong regression to use. Okay. So now we can write the polynomial with those coefficients there. So our a value is 1. So we have y equals -1x cubed plus 4x squared minus 3x minus 4. And that is all that you got to do. Okay? Pretty simple. Beautiful. One more. All right. This is probably more like one that you'll see on your test. Hint, hint, wink, wink. It says the table shows a person's billable hourly fee in dollars. Okay? So like a lawyer gets paid by the hour. Okay? Obviously, these fees are way lower. But anyway. Where T are the years and t equals 1 corresponds to 2005. That's going to be useful later, so I'm going to write that down. Find the polynomial model for the data. Okay, so we don't know what kind of polynomial this is, so I'm going to just use my graphing calculator because it's a great resource, and we're going to go with it. Okay, so let's see. List 1 needs to be 1 through 6, and list 2 is 20, 21, 15, 13, 23, and 53. Okay, then we go to our graph. Make sure your stat plots are on, by the way. Okay. Now, because we're so good at graphing from section 4.8, we can see that this right here is going to look, it's going to be like a little S-curve. And we talked in class how when you have an S-curve like that, you're probably going to be cubic. Okay, because it looks cubic, that's what I'm going to try. So I'm going to go to stat calc. And I'm going to try cubic regression. It might be wrong, but let's try it. Okay? And here's how I know that I'm probably right. My r squared value is 0.99996. Okay, that's very, very close to 1. I'm going to go with this as cubic. If you tried quartic, let me just show you what happens. So let's say that you thought that maybe it was quadratic. Okay, let's try quadratic first. And you did this. Okay, your r squared value, while it's still 0.898, that's not nearly as close to 1 as we'd like. Okay? On the other side, if you were to do quartic regression, you go down to quartic regression and you try that, the same thing happens. You're way off, okay? So you can always just try those different tests and find which one has the bigger or the more closer to 1 r squared value. So in this case, it is cubic. So now we write our polynomial. Y is equal to 1.472t cubed minus 11.73t squared plus 25.4t plus 5. Okay, that's the polynomial model. And then we want to use this model to estimate the fee in 2012. Okay, well, t equals 1 is 2005. Then t equals 2 is 2006. 3 is 2007. 4 is 2008. 5 is 2009, 6 is 2010, 7 is 2011, and 8 is 2012. So we're going to plug in 8 for our t value here. Okay, so now I'm going to go back, and I click and come back to here. And I'm going to plug in this formula, but for t, I'm going to plug in 8. So 1.472 cubed minus 11.73 squared plus 25.4 times 8 plus 5, and I get $211.14. Okay, so that means that if you work for 8 hours, that's how much money that you're going to earn. All right. Hopefully that helps. If not, come see me, and I'd love to give you some more practice problems or some helpful hints in general. So, yeah, make good choices. See you later.